Hi everyone, welcome to today's learning. Today we are going to talk about an important topic in machine learning, that is model evaluation metrics. Whenever we build a machine learning model, we should know how good our model is. Then model evaluation metrics come into picture. Model evaluation metrics are used to measure the performance of machine learning models. They provide a quantitative assessment of the model's ability to make accurate predictions on unseen data. That means these are the evaluation metrics to assess the effectiveness or quality of the model. Here are some of common model evaluation metrics which are used in machine learning. The very first one is confusion matrix. It's a matrix of 2x2 size of binary classification with one axis consisting of actual values and the other axis which having the predicted values. The number and incorrect predictions are summarized with count values and broken down by each class, which help with predictive analysis and can be effective tools for evaluating what functions the machine learning system performs correctly or incorrectly. When the actual values are true and predicted values are true, then it comes to true positive. If the actual values are false and the predicted value also false, then it comes to the section true negative. If the actual values are true but predicted values are false, then it will become false negative. If the actual values are false and predicted values are true, then it will be a false positive. Basically, it shows how any classification model is confused when it makes predictions. And the next metric is accuracy. Accuracy measures the proportion of correctly classified instances out of the total number of instances in the dataset. If the target variable are having balanced data, then the accuracy metric is very good to use. Basically, accuracy is total number of correct predictions to total number of predictions. The next metric is precision. The precision metric shows the accuracy of the positive class. It measures how likely the prediction is correct, which measures the proportion of true positives out of all instances predicted to be positive. If the target data is imbalanced, precision is a very good metric to use. And the next one is recall or sensitivity. Recall computes the ratio of positive classes correctly detected. This metric gives how good the model is to recognize a positive class, which measures the proportion of true positives out of all actual positive instances. And the next one is F1 score. F1 score is a weighted average score of the true positive and precision. Means it's a weighted average score of recall and precision. It provides a single score that balances precision and recall.
The next matrix is AUC-ROC curve. AUC-ROC curve measures the ability of the model to distinguish between positive and negative classes. It plots the true positive rate against the false positive rate at various thresholds. The area is calculated between the axis always comes between 0 and 1. And the value which is closer it is to 1, the better the model is. And the next matrix is R-square. R-square is the proportion of the variance in the dependent variable that is predictable from the independent variable, which can be calculated by dividing the total variance explained by model to total variance, which measures the proportion of variance in the target variable that is explained by the model. And the next metrics are mean squared error, root mean squared error, and mean absolute error. Mean squared error measures the average of the square differences between the predicted and actual values. RMSE is nothing but the square root of MSE, which gives a measure of the error in the same units as the target variable. And mean absolute error measures the absolute difference between the predicted and actual values. And the next metrics are Gini coefficient and Jagged score. We may not use these two frequently, but this is also more effective while building the ML models. Gini coefficient can be calculated from AUC-ROC number. It is a ratio between ROC curve and the diagonal line. If the Gini coefficient is above 60%, then the model is considered good. And Jagged score, which is the similarity index, measures between two sets of data. The score is calculated between 0 and 1, with 1 being the best. To calculate the Jagged score, we find the total number of observations in both the set and divide by the total number of observations in either set. That's all for today. Thank you for watching the video.